Hi everyone, so here is your next presentation on polynomials, and for this go round we're going to discuss multiplying polynomials. So our previous lesson was basically going ahead and defining vocabulary and taking a look at addition and subtraction. So today, multiplying. So to multiply polynomials, we're going to use the distributive property. So that means you multiply each term of the first polynomial by each term of the second polynomial, which is essentially using distributive property multiple times. And then finally, you're going to combine like terms at the end. So for example, if I have 2x plus 4y multiplied by 3x plus 2y, I'm going to distribute the 2x in the first set of parentheses. And here's where your exponent laws come into play again, because when you're multiplying 2x and 3x, the bases x and x are the same. So we're going to add exponents. And then coefficients 2 and 3 get multiplied together, which results in 6x squared. Okay, and then you're going to distribute the second term of the first set of parentheses, 4y, to both terms in the second set of parentheses. When you're multiplying, if the variables are different, then you're just going to write them side by side, which is what happens right here. 4y times 3x is what results in 12xy. You can't combine 12xy, so they just get written beside each other. Whereas when you're distributing the 2x to the 3x, since those variables are the same and it's multiplication, it's not addition, it's not subtraction, you're going to add the exponents, which are 1 and 1, to get your 2. Coefficients were multiplied to get the 6. Okay, and then 2x times 2y, the coefficients are always multiplied, so that's where your 4 is coming from. Since x and y are different, you can't combine them. You're just going to write them side by side. Okay, and then your final distribution here at the very end, 4y times 2y, is 8y squared. My bases or variables, y, are the same, so I can add my exponents. Then you're going to identify and combine like terms. So these are like terms because they have the same combination of variables with the same exponents, x, y. So combining those results in this final polynomial, 6x squared plus 16xy plus 8y squared. Okay, this is one of those things that this first example probably looked really confusing and overwhelming, but over time, as you do more and more practice questions, it's going to begin to become second nature and make more sense. So let's do another example. We're going to distribute the first term of the first set of parentheses to each term in the second set of parentheses. Okay. Now, when I multiply, and I'm going to put this over here to the side, when I multiply x times x squared, I can add the exponents, 1 and 2, okay? And when I can multiply x times 2x, since those bases or variables are the same, I'm going to add the exponents again. So I have 2 and then 1 plus 1 to get me 2x squared. Okay, and then when I multiply the x by 4, there's no like bases that I can use my product of powers with, so it's just 4 and x. Okay, and then you're going to distribute the second term in the first set of parentheses, 3, to each of the terms inside the second set of parentheses. And since 3 has no variable with it, that is a little bit easier. So 3 times x squared, 3 times 2x, and 3 times 4. Okay, so for each of these, since there's not any like bases, you're just concerned with multiplying your coefficients together. Okay, so once I've completed distributive property, these are all 6 of my terms written out side by side, and I identify my like terms, so anything with the same combination of variables with the same exponents get added together. And here is my final polynomial. Okay, so when you move on to your next level of math classes, you're going to hear a lot of instructors use the term FOIL when they're talking about multiplying polynomials. And there's nothing wrong with it. It helps a lot of students remember how to multiply, and I'm going to show it to you. I'm not a tremendous fan of it, and I'll tell you why in a few minutes. So first of all, FOIL, that acronym, stands for first. So first term multiplied with first term. Outermost on the left multiplied with outermost on the right. Inner. So your 2 terms in the very, very middle of the problem. And then the L stands for last. So the last term in both sets of parentheses being multiplied together. Okay, and really that's just a way of labeling or ordering distributive property. It is still a distributive property. It's still multiplication. The first term is distributed to the second set of parentheses. The second term is distributed to the second set of parentheses. And just like your previous example, like terms are combined to get your final answer. If it helps you to remember how to do it, awesome. If not, not a big deal. The reason I'm not a big fan of using FOIL is because it only works when you're multiplying a binomial by a binomial. And the word binomial just means a polynomial with 2 terms. So this example here is perfect for FOIL. However, if you have an example, let's say 4x squared, and then I had x squared plus x plus 3, I couldn't use FOIL to help me multiply these 2 polynomials together because it doesn't work. Because this is a trinomial, not a binomial. So what's the point in memorizing this new acronym if it's really just distributive property anyway and it only works for one particular scenario? It's up to you, but I definitely wanted to explain it before you move on to Math 2 and your remaining math classes. All right, so let's do some practice questions. Why don't you take a second and give this a try on your own? X minus 4 multiplied by x minus 3. Okay, hopefully this is the answer you got. You distribute x to both terms inside second set of parentheses. Okay, and over here, I'm going to write out for you x times x equals x squared. And then x times negative 3 is negative 3x. All right. Then you're going to distribute negative 4 to each term in the second set of parentheses. So negative 4, you have to keep that sign in front of the number, times x is negative 4x. And then -4 times -3 is positive 12. Okay, so if I take those and write them out horizontally, this is what it looks like. Then I'm going to identify my like terms and combine them. -3 combined with -4 results in -7. If I had to guess, some of you maybe messed up on your positives and negatives with this example. Okay, so here's another example. Why don't you try to multiply x plus 2 times 3x minus 8 on your own? Hopefully this is the answer that you got when you solved the problem. Okay, so walking through it step by step, distribute the first term in the first set of parentheses to both terms in the second set of parentheses. So we have x times 3x and x times -8. This results in 3x squared. There are two factors of x present, and this results in -8x. Okay, then distribute the positive 2 to both terms in your second set of parentheses such that you have 2 times 3x, which results in 6x, and 2 times -8, which results in -16. When I write these answers out horizontally, this is the result, making sure I keep all the proper signs, identify my like terms and combine them. Since it's a -8 combined with a positive 6x, that's why you have a -2x as your middle term. Again, if I had to guess, positives and negatives is what's going to start to trip people up again. Let's do a couple more examples. In this case, I think practicing is really important. So find the product of x plus 3 and 7x plus 2. The result is 7x squared plus 23x plus 6. So again, walking through it step by step, distribute the first term of the first set of parentheses to both terms in the second set of parentheses. So that looks like this. X times 7x equals 7x squared. And then you've got x times 2, which is just 2x. Okay, distribute the second term in your first set of parentheses to both terms in the second set of parentheses. So you've got 3 times 7x, which is 21x, and 3 times 2, which is 6. When I write all 4 of these terms out horizontally, this is the result. I identify my like terms and combine them to get the 23. Okay, let's try one more example together. You give it a shot first, and then we'll walk through how to get the final answer. Hopefully you were able to get this. So again, walking through it step by step, distribute the first term in the first set of the parentheses to each term in the second set of parentheses. So writing it off to the side here, we've got x times 3x, x, oops, I went out of order here. Let me make sure I go in order for you guys. X times 5x squared, and then we have x times 3x. And then I have x times -1. Notice whenever there's a minus sign, I include it as a negative for my term. Okay, so here this results in 5x cubed. This results in 3x squared. Again, it's how many x's or factors of x are present in the terms. There are 3 x's present. There are 2 x's present. And then this is -1x. And I don't have to write the -1. I can just write the minus x. Okay, Then I distribute the second term in the first set of parentheses to each term in the second set of parentheses, and that would look like this. Negative 2 times 5x squared and negative 2 times 3x, negative 2 times negative 1. And so the results are negative 10x squared, negative 6x, and positive 2, negative times negative. Written out horizontally, here are all 6 of my terms. Okay, I identify like terms, so terms that have x squared present are alike. Notice that the negative 10 combined with the positive 3 results in a negative 7. And then terms that have just a singular x get combined. Negative 1 combined with negative 6 is what results in the negative 7 here at the end. My other terms are just brought down. Okay, so that is your introduction to multiplying polynomials, and keep an eye out. I'm going to provide a few practice questions for you all in the next couple of days.